Hello, everyone. Once again, this is Extinction Week. Not what I originally planned. I had some other subject for this week, but unfortunately, or fortunately, I guess, I got sidetracked by a discussion I had with a fellow by the name of Guy McPherson. He's an extinction theorist. He's an environmentalist, conservationist. And so we had a little discussion there going on. You can see it over there in the my extinction page on Facebook. And yeah, we disagree, disagree quite a bit. Not on the fact that the extinction of man is imminent. There we seem to agree, but we disagree on the reasons. We have different proposals, different theories for why humans are going to become extinct. In my case, it's not a prediction. Okay, I want you to understand that. I'm not making a prediction when I say humans are going to become extinct. And you're saying, well, that really sounds like a prediction to me. So let me put it in the right context. What I'm proposing is a mechanism. I'm proposing an extinction theory. I can only talk about the extinction of past animals. And so I'm offering an extinction theory, in other words, how the animals in the past disappeared. Then from there, I'm projecting it to the future and saying humans are going to die in the same way. Why? Because they have no way of eluding the same process, mechanism, that these animals were forced to face. And neither technology, neither our intelligence, our ability to foresee events and react, none of that is an antidote to what's coming up, to what the other animals faced. And all that does is show that if we accept that, right? All that does is show that we're just another animal in the Garden of Eden. We're not the caretakers. We thought of ourselves as the gardeners, that God designated us as the gardeners. No, we're just another little animal there, okay? And we are from a biological standpoint, we are biologically animals. That's what we are. We eat, we sleep, we do everything that all other animals do. And it's those biological things that are going to cause our extinction. That's the general picture. I discussed the other day, first the discussion I had with Guy McPherson. On Monday I discussed mass extinctions, how I believe they occurred. And yesterday we discussed here with my son, who's on the other side of the desk here.
Hi guys.
I discussed some other issues, little bits and pieces that we kind of need to get a picture of what happened to the animals in the past that may have not been clear on Monday. And those have to do with how the plants disappeared, because what I'm suggesting is there was an economic breakdown. The ecology fell apart. The ecological pyramid overturned. You have all these trophic levels. You have on the top usually the carnivores. They are a smaller group. You have the larger herbivores on which they depend, and usually there's a 10-to-1 ratio. In other words, the herbivores, for a normal, healthy pyramid, the herbivores have to outnumber the carnivores by a 10-to-1 ratio, more or less. That's an estimate that's been thrown out there by geologists, paleontologists, biologists, and other people. And then you also have to have like a 10-to-1 ratio between primary production and herbivores. So, a healthy pyramid looks more or less like this, isosceles triangle or whatever. And what is it? It's a 10-to-1 ratio from the bottom up. 10-to-1 from primary production to herbivores, and 10-to-1 ratio of herbivores to carnivores. What happens when that overturns and it becomes like this? A triangle that's upside down, it's standing on its point, on its peak. Well, then we have a problem, because now you have the many chasing after the few. That's essentially my theory. And that's for mass extinctions. But then we have a more serious problem, because we can't even answer what a background extinction is. And the main reason.
Did you coin that term, or is
No. This term has been around, I want to clarify a little bit about that term. Okay, that's important. If you look up the term background extinction, just look it up. Dictionary, or just Google it or whatever. And what you will find is that there's no definition of that term. And yes, you go to the Wikipedia, and there's an article called background extinction. So when you go in there, what you really find is that people are talking about the background extinction rate. It's a mathematical issue. They're saying,
statistically.
Yeah. What they're saying here is, look, over the course of the history of life on Earth, while we had these mass extinctions where it's very choppy and very clearly defined, in the background you had lots of animals that came into view and then disappeared. And so they don't go to each one of those and say, well, how did this guy die? How did the Dimetrodon die? Or how did, the Edaphosaurus die? They don't care about that. They say, what was the rate? What was the extinction rate? And so they've traced and more or less made histograms, made a curve out of all this. And they said, well, this is the background extinction rate. But what is a background extinction? We have no definition of this term, just the term background extinction. What they do is just go directly to the rate. And so I had to define this term because a problem came up. You can say, well, for example, I define it as the death of a single species. And you say, well, that's your definition, Bill. Who cares about it? But there's a reason for it. If you go to the Neanderthal extinction, you say, well, how did Neanderthal die? Did he die in a mass extinction? Oh, no. He disappeared in a background extinction. So what does that mean? What was the rate? What was the going rate? What was the rock market at the time? If we're going to talk about percentages and of numbers in the background. What is this nonsense about a background extinction rate? I mean, how did Neanderthal die? Did he die all alone, or did he die in a mass extinction? Well, obviously everybody is going to say he died all alone. And so if he died in a background extinction, he died all alone, we have a definition for a background extinction. Background extinction means the death of one species. And the term background is terrible for that, but that's the way they used it. They used that as a rate, so they said the background extinction rate. That's how the word background got put in there.
I kind of like the term background because it gives this feeling like there's this party going on and one guy kind of, fades away and no one noticed. It still does apply in that sense. If only one species dies out, it's kind of like a background thing, like a side thing. Except
when that species is like the Neanderthals and he comes to the fore, he becomes very important. Or another one, very important one, woolly mammoths. They disappeared in a background extinction. And what they're saying is that all these animals, they're there and they slowly die in the background, but it's like we don't care about the causes. We don't care how they died. They just die. It's like they disappeared, and we're not concerned about how.
Yeah, it seems self-evident. Like, oh yeah, then they just died. What do you mean they just died?
Yeah,
what happened to them?
Yeah, it's like we don't care about how they died. We care about what the rate of going rate is. It's and so they never defined the term.
Well, I think it's because it happens so often that it's like you don't have to explain. It's like it's like a natural thing, so they don't question it much. They just kind of say, okay, how often do species die off on their own?
Correct. That's essentially
it's the mass ones that we're interested in. Like, okay, what happened? Something happened on this day.
Yeah.
And in this year, because we have this layer of rock that's obviously pointing to some, catastrophic
major
change.
Disappearance. Yeah.
At least change. Whatever the change was, something people started dying a lot here.
Yeah.
But when we're talking about background extinction, it's like, oh yeah, sometimes species just die.
But when it becomes important, when people say, well, how did the Neanderthals die? Or how did the woolly mammoths die? And that's when people say, well, they died in a background extinction.
Did dodo die in a background extinction?
Huh?
Dodo.
Yeah, it died all alone. And, and that's another issue that's got to be clarified, because once we bring man into the picture, if it gets very complex, because people get sidetracked and say, well, man killed the dodo, man killed the passenger pigeon, man killed the Tasmanian tiger. We crowded him out, or the environment changed, or we changed the environment for them, or brought some kind of predator into the region, or competitor, or whatever. And so they blame us. We're blamed for all modern, maybe last 10,000 years, more modern, of all the modern extinctions. In fact, we're even blamed for Neanderthal, which died like 40,000 years ago. So since 40,000 years ago to the present, we're responsible for all extinctions. Man is the cause of all extinctions. That's the way the establishment looks at this, the paleontology establishment. In general, they say, well, who could have done it? We are. So what happened to all those animals that died all by themselves before man acquired conscience?
Well, yeah, I think they attribute any subsequent extinctions to us because we have such a potent effect. I mean, we changed the landscape so much that you kind of have to say, okay, we at least had our hand in some in the extinctions of all the ones that were while we were alive.
Did we?
But that's just the first thing you think of.
Yeah, right.
Because you just say, okay, what else could be killing all these things? If I mean,
maybe it's the climate. Maybe the climate. Maybe it's the methane.
Yeah, but we put the methane there. It always traces back to us because we're just such a changing force.
Well, one of the things that we do is we change the environment. We put cement where there was jungle, and that tends to crowd out the animals. And then you get into their density-dependent birth rates and that kind of thing, and that does help drive them to extinction. I'm not going to say that doesn't. But see, we have to distinguish what man did in the last maybe 2,000 years, you could say, and what happened before then. Did the woolly mammoths die in the same way? The ones in Siberia, for example. Those died like maybe 8,000, 10,000 years ago. They're not really sure exactly when, but they died in the middle of nowhere where there were no people, essentially, Siberia. Same with the mastodons. They died before that. How about the, what is it? The short-nosed bear. He died maybe around the time of Neanderthal, maybe 30,000 years ago. How about the woolly rhino? He was there also in the days of Neanderthal, and he disappeared about 30,000 maybe or so years ago. There's a hippo. Maybe he was a woolly hippo, also in Europe. All these are European animals. They're no longer around. Lions disappeared eventually. We could have killed those, yeah. But I'm saying, we always look at, how did they die? Did we kill all these animals? And what happened before humans acquired conscience? I mean, how did those animals die? I mean, now you can't blame us for the extinction of the dinosaurs, hopefully. We were not around. And, there's the extinction.
You didn't watch the Flintstones?
And then you have the extinction of the erectus, erecti, the Homo erectus, Heidelberg. Did we kill those as well? I mean, we probably never even saw, a human, just modern human. He probably never saw Heidelberg. So how did those die? Was it Neanderthal who killed his parents? And so we got a problem here because you can blame the new ones, like the passenger pigeon and the Tasmanian tiger on us. But you sure can't blame, the ancient extinctions on us. Something else was going on. And especially Neanderthal. Neanderthal's a big issue. So what are the reasons that these people give? Well, here I put a series of issues that are brought up by paleontologists who studied the Neanderthal extinction. And of course, all of them were related to man. But until maybe the 2005, 2010, thereabouts, all of the extinction of the Neanderthals were blamed on climate, on the one hand, primarily. Climate on the one hand, and on the other, it was blamed on humans outcompeting them, just either killing them outright or using their weapons more efficiently to hunt the same game the other fellows hunted, or we had more children. There's all these theories, but we outcompeted them. That's the theory. And the climate one is also a human-related extinction theory, because we're saying that we were able to compete in the lower temperatures in the colder climates much better than the Neanderthals. So it's also a competition against human extinction theory, right? And of course, what drove them away after 2010, that's only 8 years ago, was the admixture theory. These people were waiting in the wings since about 1990s, even earlier, maybe 1980s. This theory was gaining converts, and some people were driving it at full speed, but they had no evidence, so everybody was looking for evidence. One of them was hybrids. Did humans and Neanderthals leave some kind of intermediate beast, some hybrid, half-breed, whatever, that we can say, yeah, they interbred. And since that didn't work, they went ahead with the geneticists, okay? And so the main arguments raised today are genetic arguments. What that did was put the geneticists to work. It opened what I call the gold mine for them. Thanks to genetics going into the business of the Neanderthal extinction, all these centers around the world that are doing analysis on Neanderthal DNA, oh man, they're receiving funds and they're having a great time now, because suddenly if you get a degree in genetics out of the university, you have a job. They need people like you. And all of that would have died if they hadn't pointed their fingers at admixture. Admixture is the marriage of the two species, and that's how essentially they're saying that the Neanderthals died. Here's a rundown that I have on my objections to what these people are saying. Here's the first one. There's no evidence that Neanderthals and humans ever met. The youngest human we find in Europe is 35,000 years ago. And that's in Romania. They found some human over there, and that's the earliest one we have today. I'm talking about, physical evidence, bones. And last Neanderthal, according to one of the most seminal studies, died 40,000 years ago. That means the Neanderthal died, the last one disappeared 40,000 years ago, and the first human appears 35,000 years ago. That's 5,000 years difference. We have no evidence other than that humans and Neanderthals ever met. One possibility is that there were some mingling in the Levant, especially in Israel, possibly in Iraq, the Shanidar cave over there. But there's several caves in Israel, and if you go there, you find that there was at least a lot of discussion on whether those were Neanderthals. And the jury is still out on that, even though, they try to brush those arguments aside and say, well, yeah, they were Neanderthals. I have a problem with that, because I'm not sure that Neanderthals who were born in the Arctic would have gone so far south to warm climates. But here's the genetic arguments that I have, or the arguments I have against the genetic analysis. One is that humans have no Neanderthal mitochondrial DNA. I've found at least 9 studies, there are probably more, that show that humans and Neanderthals have no mitochondrial DNA. We have Mr. Svante Pabo, he's the guru in the business. He specifically states that humans have no mitochondrial DNA. There's no human walking around with Neanderthal mitochondrial DNA today. So we have none. What is that? Why is that important? Because mitochondrial DNA is passed on from mother to children, whether it's female or male. It's the mother that passes that down. And if we don't have any Neanderthal mitochondrial DNA, it means we never had Neanderthal mothers. There's no evidence of that whatsoever. In fact, the evidence goes against it. The second one is that human males have no Neanderthal Y chromosomes. Y chromosome is passed from father to son, male to male. And at least one study, I think there's been a couple, show that humans have no Neanderthal males. Human males have no Neanderthal Y chromosomes. That means human males had no Neanderthal fathers. That's 2 down. What did they find? They did find a 2% Neanderthal nuclear DNA. And that's what the genome in 2010, the report that came out by Svante Pavo's group, that's what they published. Originally, they published anywhere from 2 to 4, then they lowered that to 1.5 to 2.1. So they kind of dropped that number. Other people found 3 to 7%. So the numbers are being played around with quite a bit. What problem do I have with that is that, look at number E there, 45,000 years ago, the Ust-Ishim human from Russia. They did a full genome on this guy. He's dated to about 45,000 years ago. He is human. He's not Neanderthal. And this fellow has also, I think it was 2.3% Neanderthal DNA. That means that 45,000 years ago, here's this human on which we did a full genome. He's got 2.3, essentially 2% Neanderthal DNA, which is what we have today. And so obviously, lots of humans in those days had only 2%, and that is easily explained by showing that Neanderthals and humans had a common ancestor, maybe 500 to 800,000 years ago. And then the other issue, D over there, Papuans and American Indians have more Neanderthal DNA than Europeans, and that's a problem. And they, throw it under the rug. They try to get people to forget that statistical data, because they always say that the way they put it, and they say that non-Africans have more DNA, nuclear DNA, Neanderthal nuclear DNA, than Africans. Yeah, great. And so how about the Papuans and American Indians who have more Neanderthal nuclear DNA than Europeans who lived and mingled and had sex with the Neanderthals? That's got no explanation whatsoever in what they do. They just sweep it under the rug. And that's on the genetic front. On the morphological front, that's how these people were built or what they looked like. And what are the morphological arguments that I raise against that? I say Neanderthals were a different species than human. For this, we have to define the word species if we're going to talk intelligently. I define it as successful interbreeding. In other words, if Neanderthal got in touch with a human and they had a baby, that baby lived to reproduce more babies, then we can say they were the same species. They may have been different races, but obviously same species. On the other hand, if a Neanderthal had sex with a human and they couldn't have a viable kid, then we're saying that they're 2 separate species. They're not just different races, but obviously different species. And that's the definition I use. And of course, you can play around with the definition. As long as you tell me what you mean by species, we're going to have a decent conversation. And then what is the problem I have with that? Because the word species, as it applies to humans, is that humans supposedly were born 200,000 years ago. Where do we get that? Well, we get that from a couple sources. One is that mitochondrial Eve, a regression analysis done on our mitochondrial DNA, takes us back to a common ancestor sometime near 200,000 years ago. That's one aspect of it. The other aspect is that they found physical specimens, and there I listed a couple of them. That's the Adaltu and Omo specimens in Ethiopia, and the Yerhud in Morocco. And they range anywhere from 160 to 300,000 years ago. So that's about the extent of the origin of humans. Those are considered to be modern humans. Assuming that's true, and again it's an assumption, that means that we could not have interbred with anyone in our own lineage that exceeded 300,000 years ago if we're going to use the word species correctly, if we're going to use it scientifically. If a species is interbreeding and our species was born anywhere from 200 to 300,000 years, I'll even give it another 100, let's make it 200 to 400,000 years ago, that means we could not have interbred from anyone in our own lineage that exceeded 400,000 years ago. If we separated from the Neanderthals, like most people believe out there, most paleontologists believe out there, anywhere between 500 and 800,000 years ago, we could not have interbred with a Neanderthal simply because there was too much time that had passed, one. And the other one is that Neanderthals developed in the Arctic climate while we developed in Africa. So we developed in two different regions. So we had to develop different DNA structure and all this stuff.
That kind of goes back to the specialized niches that we talked about yesterday,
Correct.
where if one guy's in the Arctic and one guy's in the equator long enough, we're talking about time periods here. I mean, if someone's born in the equator, doesn't mean that they're a different species automatically. We're talking about long periods of generations living and dying in the Arctic and living and dying in the equator. After enough generations, those two groups would not be able to interbreed.
Correct.
Simply
Right.
because of this niche specialization.
And what it is, Mother Nature, kind of depending on the environment in which these individuals have to live and thrive, Mother Nature kind of selects their DNA. They're saying, or their genes. They're saying, I'm going to use this gene over here against the cold, for example. And this other guy has to have a gene that fights against the heat, for example. And that's just a general example. So if the Neanderthals had to fight against the cold, and that's what they got used to, and we had to fight against the heat because that's what we got used to near the equator, near Africa, then clearly, this selectivity in our genes made us different species. And of course, I argue that Neanderthals did not wear clothes. Okay, we have specimens. Well, we have one specimen from Boxgrove, dated to about 500,000 years ago. He's allegedly a Heidelbergensis, Homo heidelbergensis, alleged parents of Neanderthals. And this individual, it's a femur. He lived around 500,000 years ago. And before that, we have flint tools and also a footprint at Happisburgh and Pakefield. All of these in England. I think I've got here's a picture of it. I've got that in my book, and if you look at the picture, you'll see what happened here. Apparently, there was some hominid living in the region that you see above, in the picture above. Okay, and what you see there is that there was a land bridge all the way to the what today are the British Isles, and there was a lake, and these hominins, they lived around that lake. They hunted, they did all their stuff around that lake, and on one of the borders of the lake was this glacier that was coming from the north. It was there permanently, and they just got used to this glacier all around them, and so they lived around the lake. They had water, they killed animals, they lived their lives there. What happened is about 300,000 years ago, the glaciers melted, covered the land, and created the English Channel, the channel that separates France from England. And that's what we have today. And so these guys kind of became isolated over there, whoever was there. They became isolated, and they probably died on the British Islands many years later, all alone in this island. They were separated from the mainland. And my point here is the following, that if there were some hominins living in England anywhere from 500 to 800,000 years ago, as suggested by Pakefield, Happisburgh, and Boxgrove, that means that these individuals, I'm sure they had no clothes. They got used to the cold, and they were living with their skins directly in touch with the cold. In other words, they probably were woolly. They had hair on their body. We could call them the woolly men. And whoever they were, whether they were Homo erectus, whether they were Homo heidelbergensis, they adapted to the cold. And so by the time they have their offspring, Homo neanderthalensis, I'm sure Homo neanderthalensis did not need clothes. He never had clothes. Hollywood always paints him in clothes and tries to make him look more human, but I think he looked more like a gorilla. He was quite hairy, maybe, and that's my opinion. But what would you conclude of this animal that lived in that region, Arctic region, he had no reason for clothes. And clothes were not invented at the time, 800,000 years ago. I don't think anybody will argue for that. So,
you're saying they didn't have the tunics on covering their private parts like they're
Yeah.
usually shown?
Yeah, well, I think the reason they dress Hollywood actors is that they refuse to do the scene without any clothes on.
Well, no one wants to see them.
No, it's not that.
Drunk.
No, it's not a question of visual. It's a question they don't want to stand the cold with their bare feet. They don't want to step on the snow like Neanderthal did. I mean, Neanderthal had no sandals, I'm sure. This guy walked with his bare feet on the snow, just like wolves do today, just like bears do today. He was an Arctic animal. He was the woolly man of the Arctic, and so he did not wear clothes, whereas we did, and maybe that's when we invented clothes, when we went from Africa to Europe. As soon as we migrated and we started finding, maybe because we were following the herds, at that point when we started feeling the cold, we were not naturally adapted to the cold, and what we did, we invented clothes. We had the intelligence to invent clothes. And again, well, the Levant Neanderthals are not really European Neanderthals. There are differences, and so the question is whether the ones in the Middle East are really Neanderthals. There are noticeable differences, measurable differences, and there were, at least in the 1990s, up to that time, many paleontologists who did not believe that the fellows in the Levant, the skulls and bones they found there, are Neanderthal. But of course, the admixture people had to invent a place where they mingled, and they insist to this day that the ones found in the caves of Israel specifically are Neanderthals, and that since there was maybe some mingling with humans coming from Africa, that's where the two species began to mingle and have fun and have kids. And again, we have no half-breeds to this day. Fanatic admixture theorists constantly say they found a half-breed, and you got to be very, very careful with that claim.
They found like 9 skulls in total, so it's kind of hard to talk about even full breeds.
Yeah, but
forget half breeds.
No, but there are some characters. If you look at a lot of the skulls, let me put ourselves back up there for a second here. If you look at a lot of the skulls found in France and Spain and so on, they match. These are all Neanderthals, and they've got a few skulls there. Again, there's like 500 bones. There's bones of about 500 individuals that we found of Neanderthals. I think it's more like 400, 450 thereabouts. In total. So from these 400 bones, we have to kind of, figure out what the story was. We have to come up with a plot, what happened. And if you look at the ones in Europe, they do match. The skulls match, the French match, the Spanish Neanderthals, they look the same. But when you compare them against the guys in Russia, you compare them against the guys in the Middle East, now we have problems. Now there are measurable differences, and they kind of squeeze the guy in and say, well, yeah, he's within the range of Neanderthal. Maybe he wasn't a Neanderthal. More than likely he wasn't. There's just too far south from where the classic Neanderthals were in Europe. The final argument I have essentially are the social arguments. Just before I do that, let me show you one more thing here. And that's, again, if we wore clothes and Neanderthal did not, and he was the woolly man, I think he looks more like Boule had him drawn by an artist in 1909. That guy on the right over there, that's what Boule thought Neanderthal looked like. Well, obviously that's not what they make him look like today. Today he looks more like a Hollywood actor, blonde, blue-eyed. He's gotta draw the girl's attention. Otherwise, what girl would sleep with that monkey? Nobody would do that. But here you can see a contrast. First in the skulls, then in the body structure. The main part there, the pelvis and the rib cage. And then you can see also that there's that's my opinion here, right? But I would think that humans, if they ever met, humans would have been dressed, and their heads would have been different, and Neanderthals would have been undressed and with quite a bit of hair, more like a gorilla, a monkey, or whatever, a chimp, and their heads were also different. So they look different. I don't think too many women would sleep with that monkey, and I think that's what they were essentially, some kind of European gorilla or sorts. And then, okay, so the last arguments I have against this is the where do I have it? Somewhere I had it here. Social arguments. Here it is. Social arguments that you have to look at what was their social structure. My opinion is that both the humans and Neanderthals, they had clan structures. I think the clan structure is the typical structure of the Paleolithic, and maybe even before. And so you fight for the clan. That's your country. That's your flag. That's your national anthem. And the other clan is your enemy of your own species, let alone of a different species. So there is no friendship, as far as I'm concerned, in the basal hunter-gathering world.
Well, hold on, but didn't the way you frame it, it sounds like they only intermarried within their own families, within their own clans, and never talked to any other clans.
Uh-huh.
Is that accurate?
Essentially, yeah. Essentially, it's like chimps. Chimps today, they kill other neighboring tribes or clans or whatever you want to call them. This group of chimps hates the chimps from across the street, let alone gorillas or something else. They would react violently against a gorilla entering their lands. But they fight against other chimps. And you say, well, how do they have kids? Well, a lot of that is done by young chimps leaving the clan. And young girls, young females leave the clan, and young males leave the clan. It happens also among the lions. The females, the young females, they leave the clan, they wander off, and so do the young males, and they find themselves out there, and they form a new clan if there's enough land, if nobody chases them out, or if they are able to defend their land. And so, we can imagine this happening also among Neanderthals. There's also probably rape, even though I doubt that, and one of the reasons I have a problem with rape in the wild is that, no monkey, no ape, no human, especially hunter-gatherer, or no Neanderthal, I think would have ventured too far from the clan. And that's not because they were going to be raped. It's because, the jungle is a dangerous place. A lion can pounce upon you. So you're not a little girl that goes out there and picks flowers in the meadow, because you don't know what might come at you. It could be any animal. So you have to be at least within shouting distance of the clan. So for to say that Neanderthal raped a human female, and she makes all these cries and nobody comes to her aid, I don't think it ever happened. Females did not stray far from the clan. A hunter-gatherer is a quite smart individual if he's going to survive, and one of those is that he's got to stay close to the clan. He's got to be within shouting distance. And there are no microphones in the jungle, okay? You can't just, call, no cell phones. You can't call your father, mother, your brother, whoever to help you. No, so you do it by distance. You can't venture too far from the clan, and you better come home not late at night drunk, but you better be sober and come home early. So the custom of a hunter-gatherer, I think, is very different than what we imagine today. And the other one is that, humans were different socially than Neanderthals, because we were nomadic. We were coming from Africa, moving into Europe, and assuming we met and we were there when the Neanderthals were still alive. The Neanderthals were, on the other hand, sedentary. They were no longer moving anymore. They were not wandering. They essentially had staked their grounds. They had their clans for living in the region for a long time. They would reproduce, and I think that's part of what gave, what caused their extinction, the fact that they were endemic. and they also had to deal with endemic diseases to which they got used to over time. At first, the diseases might have killed them. Later on, they just made them sick, and eventually, maybe they were immune to them by simple nature. After thousands of years of being exposed to them. And then again, the allegiance was to the clan, and it's like any other great ape today. There's other causes like diseases, the fact that we outcompeted or outgunned them, we had better spears. I think all that's nonsense. Climate change. I'm not sure that the cold weather would affect Neanderthal, because it would affect woolly or some other animal much faster than Neanderthal, because Neanderthal did use fire. And if Neanderthal had fire, he had an advantage over all the other animals. And again, when the climate gets rough, the rough get moving. And
why would they have fire if they're already warm?
No, it's not a question for heat. I think they used it maybe for defense primarily, and perhaps to cook their food. Maybe they, I don't know, it's a possibility that they cooked their food. If they did, just by sheer coincidence, without them knowing, they were killing the bacteria that could affect them also.
Why do you assume that they had fire?
They found hearths dating to like 50,000 years ago. Carbonized areas, near stones and so on. So pretty much established that they used fire. What they used them for, was it to burn their wives? I don't know. It could have been anything. But more than likely, they probably cooked their meat. Another one is they probably realized that it's a good defense against wild animals like, cave hyenas and lions and so on. They could use fire to scare them away. So maybe that's how they use this. And I'm sure humans used it in the same way. Anyways, the bottom line is, I doubt very much, extremely, very much, I'm very skeptical of claims that humans and Neanderthals interbred. And again, there's no mitochondrial DNA data to back that up. In fact, it's against admixture. So is the Y chromosome data. The only data, which is very tiny, is the nuclear DNA. We do share about 2% nuclear DNA with the Neanderthals, and that is clearly or very easily explained by saying that we had a common ancestor, not 50,000 years ago or 40,000, but 500,000 years when we parted company. So that's in a nutshell my argument against admixture, which is the reigning theory. And again, it's like a lot of this math stuff that we see in physics. Once these people impose it on the masses, and the masses are not careful and just accept the word of the so-called experts, people start believing and spreading these theories without analyzing them in any depth. And I have a problem with that, because if the theory is irrational, it's nonsense, then we should discard it. That's in a nutshell my take on Neanderthals. How did Neanderthals die? Neanderthals died in a different way. I think they died of old age in a nutshell.
Is that how background extinctions work typically?
Yeah, all background extinctions, not all. I can't vouch for the ones since man came around, because that introduces some complexity into the picture. We do crowd out other animals. But in general, before man gained consciousness, and we can say maybe up to 4,000, 5,000 years ago, we're talking about the Neolithic age here, the beginning of agriculture and so on. Until that happened, before then, I think all animals died naturally, and what do I mean by that? I mean that they became old. And what do I mean by old? I mean that their genetic they suffered genetic drift over thousands and thousands and thousands of years. So by the end of the species life, or near the end of a species life, they had lost most of the genetic diversity. That's one issue. And the other issue is that towards the end of their life, they also became endemic. They became sedentary. I think that happens to all species just before they die. Humans are now sedentary. 8 billion people on the planet, we all pretty much live wherever we are. We don't do any exploring anymore. We don't find new continents. We found them all. There's no massive movements like it used to be in the past. In the days of Neanderthal, in the days of Cro-Magnon, everybody traveled because there was no visa, no passports required. You can just go anywhere you want, and people just settled the land. And today the land is settled. In fact, today we're not creating new cities, other than a couple in China. But other than that, you won't find new cities in Japan. You won't find them in my country, in Argentina. You won't find them in the United States. We don't create new cities anymore because all cities that will end with the world have already been discovered, founded, populated, and if anything, they'll just keep growing. But no new cities will start. And the reason for that is that we have no new people. The people that are born, they stick to the city where they're at, or move to another existing city. They don't go out like the pioneers, cutting forests out there and starting a new city. It doesn't happen anymore. At least not, there might be a case here and there, but certainly it's not the primary mover of migration or people movements on the planet. We're sedentary. We're a sedentary species. Wherever you are a sedentary person, whether you travel or not. So this migration, pioneering kind of work, that's over. That happened a long time ago. It no longer happens today. And what does that mean? It means that if we are endemic, if we are sedentary, like the Neanderthals likely were at the end, and I think all species that become extinct in a background extinction become endemic, become sedentary at the end. Those simply live their lives. They get used to they're living their golden age. They're happy where they're at. They got used to where they're at. They're not going to evolve anymore, not radically, and that's where they die. And you do have the case of the redwoods in California. They're endemic. The only place you'll find them is there. I mean, I think they've moved some of the seeds or some of the trees to other parts of the world because they want to kind of stimulate the growth of redwoods and other trees similar to those. But essentially, the redwoods ended up in California. And what you got to remember is that, in the days of the dinosaurs, 65 million years ago, the redwoods were everywhere. It was a very popular tree. Today, it's a little, handful over there in California. What happened? All the others died, essentially. The land was taken over by other plants, and the redwoods slowly ended up in California. That's where that's the final island in which they're going to die. And the redwoods are an old species. I'm sure of that. Part of that giveaway is the fact that they live to such old ages. They live like 2,000 years. They're big. Another giveaway, another clue, another footprint. When you have a large tree and it's old. And the third one is that many people are not aware, but the redwoods have developed an antidote not only to bacteria and other diseases. Nothing kills them, but worse, not even fire affects them. They develop some kind of rosin on the outside of their skin, on their bark, that you can't burn a redwood. And so they've got an antidote even against fire they've developed over the thousands of years. So a redwood is a dying breed. It's in the last stages of. It doesn't mean it's going to die in a year. In the case of plants and trees and so on, they last millions of years. So maybe they're just in their last million years. But the redwoods are not going to expand, assuming we remove everything out of here, we remove humans and other plants, the redwoods are not going to expand. The redwoods die in California. That's their last stand. And I think the same thing happened to the Neanderthals. The Neanderthals were stuck in Europe. They got used to the nice life they had there, just like Heidelbergs before them and maybe Homo erectus before them. And they got used to the conditions there. They had no reason to migrate. They didn't migrate, I think, at the end. They just stayed where they were. And that's where they died. They died when their population pyramid overturned. Partly, that's half of the story. The other half is that they lost their genetic diversity. So I'm sure they had all kinds of genetic problems towards the end. And they have found some specimens with regarded as genetic problems, but I don't think they're identified properly because people don't really think in these terms when they're going out there in the field. They're thinking, what killed this guy? Instead of thinking, well, maybe something biological was going on inside his body over the generations. And I think if we had God's eyes, we could go back there and we could see that the Neanderthals suffered, in the end, genetic diseases. And today we're suffering the same kind of diseases today. You see all kinds of genetic diseases today which have replaced contagious diseases and as the primary driver. And it's because we've been intermarrying for so long. Who are you going to marry? You're going to marry another human. And more than likely, you're going to marry someone from your town or nearby or from your culture. And what does that mean? It means that all you're doing is inbreeding. You're propagating the inbreeding. That's why we have, I think, so many autists, homosexuality today. I think it's related to that, the fact that we've been inbreeding for so long. And I think that happened also to the Neanderthals. I think it's happening to the lions. You see lions in their last stand. There were like 135,000 lions just 50 years ago. Now there's only 35,000 lions. So they're dying, no doubt about it. Now you might say, well, it's because we're crowding them out. Well, that's part of the reason, no doubt. But so we're accelerating their demise. That's all we're doing with that. But there's also another issue that, lion has to marry a lion. And who's he going to marry? The lion across the street, He kills the lion who's the Lion King. He becomes king. He takes over the harem. And what's he going to do? Well, you might say, well, he's a different lion. Well, maybe not. He's a cousin of the guy he killed. So we have marriage of cousin. We have inbreeding, extensive inbreeding. And I think that's part of what's happening in the lion world, among others. Hyenas, they're less. There's only 10,000 hyenas. And cheetahs, there's even less. Wild dogs, they're even less. So we have very few of these animals. They're just for tourism today. They have no purpose of being. They're just undergoing their last stages of, until they reach extinction. And we might say, well, we're 8 billion. Yeah, but 8 billion can die in a second, in a matter of weeks, a geological second, matter of weeks. Why? Not because of inbreeding, which we are doing, but I think the economy is going to beat us to it.
Yeah, but that's got nothing to do with background.
No, of course not. Of course not. That's why I just mentioned that in passing. But yeah,
so background. You're saying all these animals, these species, for example, in Africa, are all collectively dying of background extinctions?
No, they're dying in background extinctions in the sense that they're competing who dies first.
Yeah. But
if you look at the numbers, it's like they're all collapsing.
Yeah, but why are they all happening at the same time?
Partly because we have, and that's where it gets complex. Because all these conservationists and wildlife managers, they blame us. They say we are the cause, and to some degree that's true. We are putting cement where there used to be jungle, and that kind of shrinks the habitat of the lions, of the cheetahs, of all these other animals. But I think there's another issue going on, and that's that even if we remove humans, let's kill all humans tomorrow morning, all 8 billion of us, what would happen to the lions? Would they expand and propagate and get bigger? No, I don't think it would. First, they're sedentary. They live in the regions that they have already staked. And you would say, why doesn't a lion go farther out? Well, they don't. There's not enough population to drive that expansion. That's one issue. And the other issue is that I think they lost their genetic diversity. If you look at the diversity among many of the animals in Africa, not to mention the ones that we commercialize, like cows, chickens, and pigs, and so on, they lost all their genetic diversity. There are no large mammals with extensive genetic diversity. There's no such thing today. We lost it over the centuries. In fact, a famous study by a British team, and I think it's been corroborated a couple times already now, and that's that chimps in a region of Africa, right where the Africa turns the corner in on the Atlantic, In that region, they did a study and they found that a group of 50 chimps, troop as it's called, has more genetic diversity within the troop than all of the 8 billion humans. In other words, if you look at the genetic diversity between a Chinese, an American, and a Russian, a South America, an African, we have much more commonality among ourselves than this group of maybe 50 chimps that belong to a single troop. And you say, how can that be? And I'm saying that's got to do not with, it's got to do primarily with the fact that these animals are at a given stage in their genetic diversity depletion. So if you draw a curve from the beginning of the species to an end of the species, you will find that it loses genetic diversity through the process of founder effect and crashes and so on, population bottlenecks. And it's going to lose its genetic diversity over time. And humans are simply more advanced in that curve than are the chimps. That's all it is. We're looking at, if we go back in time to our own lineage, we go back to 50,000 years ago, we would certainly find, no doubt about it, more genetic diversity among humans in those days than we find among the 8 billion humans today.
What are examples of animals with high genetic diversity?
None.
Then what do you have to contrast it to?
Well, you do have to contrast. There are some out there that have more than others, but to say high, it's difficult to say high because if we compare ourselves to the sheep or against the cows or any other animal that you choose, whether domesticated or wild, you would say, okay, we have more or we have less than such. Like we have more genetic diversity than cheetahs. Cheetahs are one of the animals, one of the mammals, one of the large mammals that have the lowest genetic diversity on Earth, and there's very few of them.
Well, I guess the question is the reverse. What's the animal with the highest genetic diversity?
I don't know that answer. I'd have to look it up.
Because you're only looking for things with low genetic diversity.
No. That's not the point. The point here that I'm trying to make, at least as a theory, okay? I'm just proposing
here.
Yeah,
but it sounds biased. That's my point. You're not looking for the other end.
No, it's that you probably won't find. I don't think you'll find. I mean, I looked at a lot of them. I haven't looked at all the animals on Earth, but I looked at a lot of the big animals on Earth. And,
well, yeah, I'm talking about small animals.
Oh yeah, but then what is it?
You think the natural thought process would be to get the other end of the spectrum to kind of have a contrast of what you'd find at the newer ends and what do you find at the older. Right now you just have the older ends.
Yeah, in that sense, I have not done a full study on that, and all I can say is that the big animals, both wild and domesticated, they have very low genetic diversity. Whether you look at horses, whether you look at zebras, you look at any animal, very low genetic diversity.
By low genetic diversity, you basically mean we're all clones of each other.
We're all clones, and they just say, when they do these studies, there's low genetic diversity. This guy has a little more, this guy has a little less, but they're all very low, relatively low for what you would consider a species that's supposed to live another 1 million, 2 million, 10 million more years. It's like something's going on where they lost their genetic diversity, and we cannot imagine how these guys will continue inbreeding and end up, forming, great masses of animals. And that applies to humans as well. It's just not going to happen. And maybe there are some smaller animals. I don't know. I'd have to look at that.
But I guess the question is, like, for ants, for example.
Yeah. It's a valid question. It's a valid question.
You think they're all clones of each other.
Yeah, but see, it's the queen that matters in the case of bees and ants, not the ant. The ants are all clones. They are. The workers, they're all clones because they're all made by the queen.
So you have to find out what potential the queen has?
Yeah, you got to compare queen against queen because the queen is the only real unique animal in an anthill. All the others are just clones. They're just slaves that work for her. So she's the one that gives them something to do. They put them out in the world. They're all the same. But it is a valid question. The way I look at it, simply from not from an evidence point of view, which is what you're looking for, but from a reasoning. I'm just trying to rationalize this, and I'm saying that there's got to be a curve due to founder effect and bottlenecks. There's got to be a curve in which genetic diversity drops over the centuries, over the thousands of years for any species.
Yeah, but you can't really. We don't have God's history book to know how old the species is. So.
But we do have a couple data points, and one of them is on the Neanderthals. In fact, there's an interesting study. Now again, they don't have too much data, but they found when they did the genome, they found that, and one of the reasons that they rejected a couple samples was because of this. They found that a sample that was found about 75 to 80,000 years ago of a Neanderthal, compared to three of them, in fact, found anywhere between 45 and 60,000 years ago, that 45 to 60,000 years ago, even though they were in different regions, one was in Spain, the other one was in Vindija, the cave in the old Yugoslavia, these had more similarities in their genetics than the guy 80,000 years ago. So they said, this guy who was an older guy had more genetic diversity than these guys 20,000, 30,000 years later. That they have determined. But there's only one data point. But I'm sure, you'll always see it that way. You'll find that it's a curve for any species. And if you want to know how close a species is to becoming extinct in a background extinction, all you got to look at is their place on that curve. If you could determine that curve, you got to look at the position of that species on the curve. If it's got very low genetic diversity, it's about to become extinct. That's my general thought on that. And with that, I will see you on Sunday, and hopefully, I'm praying to God, hopefully I'll get that second installment on real physics, so keep an eye out for it on Sunday. I'm going to try to see if I can upload it by then. Okay? We'll see you then. See you on Sunday.